Our agenda for this evening. Up first is Thomas Wood, who's the director at Fast Data Science. He's going to be talking about Project Harmony, which is a super exciting use of large language models to help with harmonization of medical data. Then Vikram Haridas, lead product manager at Groupon. He's talking about implementing AI-driven product innovations and the strategic insights and the practical innovations that can be found there. Finally, last but not least, we have Shubhangi, Goyal, and Nidhi, Agrawal, director at UBS and data analyst at ICS, who are talking about generative AI and its use cases. So, I will hand over to our first speaker. Oh, hang on, sorry. Sorry, Thomas. This bit is usually delivered by someone else, can you tell? So, very, very quickly, before we hand over to our first speaker, as I mentioned before, the long-term sponsor of this event is Daemon Solutions, who very generously sponsor all of our AI and deep learning events. So, any of them with a number at the end, they have sponsored. They are hiring at the moment. If you are a software engineer, if you're a cloud engineer, if you're a data scientist, they would like to hear from you. They're a really friendly bunch, so please do check them out. They are very generous in supporting all of our events. I'll leave that QR code there for a couple of seconds for those who are interested. Cool. And sorry, Thomas. I will now hand over to our first speaker of the evening. A big round of applause for Thomas Wood.
Thanks very much, Ian.
Sorry, Thomas. I will now hand over to our first speaker of the evening. A big round of applause for Thomas Wood.
Thanks very much, Ian.
Thank you. My name is Thomas Wood, and I'm going to talk about a project called Harmony, which is an open source project. It's a tool that we've developed initially for psychologists and other social scientists, and it's for something called harmonization and data discovery. And this is our website. I've got the Wi-Fi network up here in case anyone still needs it. So you can find us on harmonydata.ac.uk. And this is me at the bottom, Thomas Wood, Fast Data Science is my company. So Harmony is a project that at the moment we've got a team of about 6. There's myself, and then Owen, Bettina, and Mauricio and George are all psychologists in universities, mostly in the UK. So Owen's in Ulster University, Bettina's in UCL, George is in UCL, and Mauricio is in the university in Brazil. And we've got myself and John Rogers. And it's an open source project, so we've had contributions from around the world, people making pull requests on our GitHub. And the project's been funded for a couple of years by the Wellcome Trust as part of an award scheme called the Wellcome Trust Data Prize in Mental Health. So that was a bit like the Dragon's Den, where 12 teams joined it initially, and then we had to pitch, and we went through a round, and we went down to 5 people, then down to 5 teams, and then down to 3 teams, and so on. Now we've moved on to some UK government funding, so we're funded by ESRC, Economic and Social Research Council. And yes, so what the project is about, I'll explain the problem. So psychologists, unlike other kind of, people in other areas of medicine, have to measure things in a very different way. So let's say we know doctors might measure things like blood pressure, and they'll use a set of numbers, and everyone agrees on those numbers everywhere in the world. Psychologists, when they want to measure and quantify something like anxiety, depression, ADHD, autism, all these phenomena that they're given a label to, they have to come up with a way of quantifying that often without taking a direct measurement of somebody's blood pressure or so on. So what they use is these questionnaires. So we call them questionnaires. Psychologists refer to them as instruments. And these are a series of questions that you answer often on a numeric scale. So one of the best known is this one, the GAD-7 anxiety scale. So that's 7 questions. Each one is answered on a scale of 0 to 3. I think, 0 to 3. So that means the maximum score you could possibly get would be 7 times 3, i.e. 21. So that would be a high level of anxiety. And then if you answered 0 to all questions, your total score would be 0. Okay, and so that's all nice. That would be nice if everybody agreed and used the same questionnaire, but we don't. So I've got another one up here, which is the Beck's anxiety inventory. And if you had data or answers about one individual gathered with the GAD7, you have data about another individual gathered with the Beck's anxiety inventory, how can you combine them? So somebody's going to have to go through manually and decide item number 4 on the GAD7 is an approximate or a very close match to item number 4 on the Beck's anxiety inventory. The numbers are just coincidental, and sometimes there's no match, sometimes it's a partial match. And that's a bit of a headache. And let me give you an example of why you might want to do this. So imagine you wanted to hypothesize that anxiety levels have increased in the lockdown. So you've gathered a load of data using the GAD7, but you don't have enough people that your error bars will be small, and you could have a statistical power to say anxiety levels have definitely increased, or with a p-value of 0.05 anxiety levels increased during the lockdown. So, but imagine you have a data set from London using the GAD7, data set gathered in Manchester using the Beck's anxiety inventory. Then you could start to combine things. And so this becomes more relevant when you start to look at the huge number of questionnaires. So just for the topic of anxiety, we've got up to, I think, around 200 widely used questionnaires. So here's just the first 3 off the top of my head. And yeah, it's a huge headache combining them. Once you are doing any kind of multinational study, then you start to find that other countries use other instruments, and sometimes it's a translation, like there's an official translation into Portuguese of the GAD7 and into Chinese and into Arabic and so on. But this is an instrument that's just used in Brazil, so that becomes a bit more of a problem. So and that's also an issue if you were combining data across time, which is a long-term longitudinal study. So sometimes there are studies where people have followed a group of individuals born in the 1970s, and they follow them up to now. And back in the 1970s, there was a different instrument used from the one used today. So what my colleagues, the psychologists, have been doing, let's say data analysis that they did, was they took something called the Millennium Cohort Study, which is an amount of data collected over a period of 24 years around children who were born at the turn of the millennium, so in the year 2000, still collecting today, so it still goes on, and every year they ask them a load of questions, then they measure things like anxiety, they would measure school attendance, all kinds of things. And then they've got, they wanted to do an analysis of anxiety levels in adolescents and compare the UK and Brazil. So they took another study, which is this one called the Brazilian High-Risk Cohort Study, and they were able to combine the two of them using this harmonization technique, despite the fact that the questions asked were in different languages. So, and then how this looks manually, so it's traditionally been done in this really tedious way, which is a load of spreadsheets that everyone gets together in a kind of meeting called a harmonization committee. And the people in the harmonization committee kind of then decide, okay, item number 6 on the SF36 is about low mood, and item number whatever on this other questionnaire is also low mood, therefore we match them together and we will combine data in that way. So then, obviously in the era of generative AI, there are more fun things you can do. So if what we've got here is we've made this web-based application that allows you to upload the instruments. So I'll show you what some of the instruments look like. So they're often, they come in PDF form and they're kind of an arbitrary format. There's no kind of unified structure that they all follow. So here's a few of them. So what we've made is we've made a tool that will let you upload one of these PDFs, and it will process it, pull out the questions. You can also select items, or things from a drop down, and you can then harmonize your instruments, and this will use large language models, and it will identify what the similarity value is between individual items. I can change a threshold, my tolerance, and so let's say here what it's telling me is item number 3 in PHQ, Patient Health Questionnaire, is a 71% match to item number 1 in the Portuguese GAD7. And then if I want to filter, let's say, anxiety only, I can type in a search term here. I can change the threshold. I can also export the similarity matrix as an Excel. And so I get kind of a list of all the match pairs and a matrix, because obviously like it's, you know, you have n by n, upload a total of n items, you'll have n times n minus 1 divided by 2 item, or n times n plus 1, rather, divided by 2 matrix values. What we've also got is we've got a bit of an integration into some external data sources. So there's this is a partner organization called the Catalogue of Mental Health Measures. So Harmony detected that the topics that I uploaded included anxiety and alcohol use and so on. So at the moment, this direction of integration is just constructing a URL, but we're working on a smarter integration. And this will show actual studies and sources of data which the academic can apply for. And what we've also got now is we've got a route back from this site into Harmony. So I can now, so there's an import link going back in. So researchers can find data, they can import them and export them. So let's see. Yeah, the next thing we're working on now is data discovery. So this is where it gets more interesting, because what I've shown you so far is when you've got a PDF and you want to upload it, and you know you've already got a load of these PDFs. The next, what happens if a researcher wants to know, is there any study on anxiety in adolescents, or or study on anxiety in adolescents focusing on females between ages 15 and 18 and things like that. So what we've started to do is index every study and every variable that has been collected by research groups in the UK. So things like, let's say the Millennium Cohort Study will be in there. So and what I've started to do, so this is kind of an ugly front end, because this part we haven't made the back end. We've not fully made this as an API and front end yet. This is the part that's in progress. So the nice thing is we've indexed all of these by vectors. So everything has been turned into a vector, every variable that has been measured. So if somebody has asked a teenager, do you feel anxious when you're at school? That's been turned to a vector and that's been indexed. So I can search, let's say if I search for the word anxiously or anxiety or anything like that, I can find studies that have an approximate match with that term. I can find variables. So here it's got, let's say this one, patient ID somehow came up. Oh yeah, fearful, this one, I wrote anxiously and it's brought me up this one, which is where the question asked included the word fearful. So we've got a lot of, let's say, a lot of potential to allow people to now use this for data discovery. And I can segment things by, let's say, by the topic. So we've got emotional states is the commonest topic in the items that I've retrieved. So we're working on that, and we're going to. This is what is basically ideally going to look like. This is kind of a mock-up that you'd be able to search on this platform for depression, ADHD, autism, and you would find studies on autism. And you could, if you searched for autistic, you would also find a study containing the word autism, because the large language model would have got it. So question is how the tool works. So there's a few very tricky parts that we had to work on. The first one is the PDFs. So the PDFs have all kinds of horrible structures that they're completely internally and externally inconsistent. So we had to do a lot of training of models and to work out where the questions are and where the response options are in a PDF. So one of them might structure at the table, one of them might use bullet points, one of them might use numbered points. So that's one that we've done things like run hackathons, and we've put we made a training data set and we put that online. And we're planning to run an online challenge to just invite anyone to participate and help us improve that, because it just doesn't work very well. Once questions are extracted from a PDF, we turn them into embeddings, which is a vector that represents the meaning of that sentence. And then we calculate the similarity of those embeddings using a cosine distance. So what I can do is I can probably demonstrate a bit what these embeddings look like. So this is a little online demo that I made, where if you have a sentence like this, I like dogs, another one like, I like cats, we can turn them each to a vector. And these vectors, in this case, I don't know, I think they're length 500 or so. And the cosine similarity comes from the dot product, which would be this times this plus this number times this number. So the large language model can generate this for each of them, and then it will give you a similarity value between the two of them. So if I were to write something like, I feel depressed, something very, very different, we start to get a very different cosine similarity value, 0.32. So what we've done here is, we've exposed Harmony as a Python library, so you can just install it using pip. You can install it in R as well. So you can import it, and you can do things like, I'm going to convert a single, let's say a single sentence to a vector, and you can see what it looks like. So let's say sad, I feel sad, it's just a massive array. Happy, and we can try the Spanish for I feel happy, Spanish for I feel sad, depressed as well. So, and if we want to see what the cosine similarity is between two of these, Harmony would say I feel sad versus I feel depressed is 83% similarity. Sad and triste is 99%. So this is showing the multilingual aspect of it. It doesn't really care what language it's in. If it was English versus English, it gives 100%. But English versus Spanish, things that should be 100% match are often around 95% match. And then English versus very different languages like Chinese, it still works, but what you would expect to be 100% match might be an 80% match. And so and we can see the same, like sad and then happy in Spanish gives you 47%, and happy feliz is 99%, 98% again. So it's really amazing how it just works out of the box like this. So we're using the large language models that came from Hugging Face. So we didn't make them. We're hoping to train our own large language models. So essentially, the large language model is converting any sentence into a vector of length 1. They would be, so you can imagine them positioned on a massive sphere. So if we were in 3 dimensions, it's really easy, or 2 dimensions, it's really easy to visualize. We're in 500 dimensions, it's really hard to visualize. This is the closest I could get. So sad and depressed are very close together in this vector space, and child is bullied is further away. So we found it's really quite effective, but there are a lot of points where this similarity isn't quite doing what we would like. So that's why we want to, instead of using the large language models that you can take off the shelf. So there's the Hugging Face ones, which are open source. There's also OpenAI. None of them quite do what we want, because we're in this psychology domain, which is different from the domains that the large language models were made. They were made, they were trained on the internet, or they were trained on the Wall Street Journal, or on whatever's been scraped off Google, or probably whatever OpenAI wasn't supposed to use, but they did use. And so, how do we? So I was thinking, one of the things that I frequently see happening in Harmony is you input something like, I have trouble sleeping, and then you have one like, I feel sleepy, and it thinks those are similar. So it groups together any topic to do with sleep. And because all of these questionnaires have stuff around sleep, we actually want to be more, better at distinguishing them. Then conversely, there are things like, this isn't quite to do with harmonization, but it's an interesting effect that you see with those questionnaires, that psychologists can take data gathered with those questionnaires for 1,000 people and look at correlations and see what items are correlated, and you'll find things like sweating and increased heart rate are highly correlated because they're both symptoms of anxiety. And a large language model would never pick up on them because semantically they're entirely different. So we've evaluated, I mean, this is a bit hard to see, but we did a lot of evaluations taking both the manual harmonizations and real world data sets gathered on, people where they answered the GAD7 and so on. And we found, for example, the OpenAI and the Google large language models are better than the off-the-shelf free ones that we can use. And what we've done is we've worked out the real correlations, let's say taking that real world data, taking Harmony's prediction and plotted it on a graph. So here on the x-axis, we've got the cosine similarity. That's, essentially the dot product between the two vectors that came out of Harmony. On the y-axis, we have the real world correlation. And there's a bit of difference between the two. So the real world correlation, tends to, let's say if two things are not very highly correlated, their real world correlation is about 0.5. If they're well correlated, it might go up to 0.8, 0.9. Harmony is a slightly different range, so Harmony can go down almost to 0. But yeah, so there is, in theory, maybe there's a possibility that we could use Harmony to predict how well two things would correlate in the population by calibrating it. So that one is something that we've just had a publication in the British Medical Journal of Psychiatry. So that's been published about a month ago. So this whole thing is open source. It's on GitHub at this URL, github.com/harmonydata. We originally intended it for psychologists. We're now kind of branching out. Now we've got the UK government funding, so it would be for researchers in any area of social sciences. The license is MIT, which means that if you contribute to it, your contribution goes back there, it becomes public. It doesn't force anyone to, let's say, to use it and make their contributions public. So it means people could still take it and use it for something commercial. And I think there's a lot of commercial applications for this kind of thing as well. It's not been monetized. We have no plans to monetize it. We're doing things like running hackathons, both in person, possibly at CIVO Tech Junction. We've already run one hackathon. We've got some online hackathons as well. And we have a Discord channel. So that's the QR code to join the Discord. So anyone who wants to work developing it can join there and message me or message the team. And then what I'm starting to look at is uses outside of psychology as well. I'm always interested in hearing also, like, there will probably be someone in the room who works in a field that I have not even considered that this would have a use for, because every time I talk about this, somebody comes up to me and tells me about something from their discipline that, where they think this would be a brilliant idea. So one of the things that came up at some point was, so some areas of medicine. So there are a load of instruments that assess people's risk of contracting HIV. So this is one of them. There's NHS medical records. So every separate trust and CCG in the NHS has their own way of storing data. And if you move house, or anyone who's ever had a child in a hospital in the UK and been given like massive folder of like 500 sheets of paper, will be familiar with how the NHS does these things. So so these are some of the NHS medical history forms, and and then there's these ICBs, integrated care boards, which have data sets which are often kind of very different schemas. So it might be interesting for doing things like data analyses across the NHS. Market research, so occasionally some market research organizations, they often have these surveys where they would ask people in every country, how do you like this packaging of this new coffee? Then, how much Coca-Cola do you drink? How much other fizzy drinks do you drink? And they will ask that in every language. And then harmonizing that, I'm pretty sure is something that needs to be done quite often. In pharma industry, so clinical trials have loads of these data points which are stored in plain text. So every clinical trial, for example, has an endpoint, which is the thing that they're going to measure. Sometimes that's the GAD7, sometimes that's blood pressure, sometimes that's, so one trial might annotate it as just blood pressure, one trial might, write MMHG or something else. And so like harmonizing those kind of things, I'm pretty sure there's a load of potential there. Finance, in finance, they have things like industries. Let's say every company that makes. So I did a bit of contracting for a company that did some of this, where they would have investments or people asking about their investments, and they would have a data set with a column for industry, and every client would annotate industry in a different way. So some of them would have a list of 100 industries, some of them would have 200 industries. So, there's all kinds of things that I think we could use this for. At the moment, we've got a few kind of hanging open tasks on the GitHub repo that we think it would be really cool if anyone wants to pick them up or get involved. Things like making a browser plugin, integrating with a load of different platforms, perhaps those, so like what we've done with the mental health catalog. I think it would be really cool to have a PDF export. So, you get this view, at the moment you can visualize your response with your results from Harmony in the browser, or you get that Excel export. We don't have a kind of nice human readable PDF report, which I think would be really cool to have. There's also, if somebody had a data set, so that where it would be like columns and then rows for each person that they've collected, let's say anxiety data on, we don't handle that at all. Part of that has been, we've been a bit worried about the minefield of allowing people to upload personal data. But if Harmony were to allow you to just download it, let's say were to generate a Jupyter notebook or something that you could download and do that part of it locally, that would be a really nice solution. Maybe more people would use it. So we're looking into doing things like making a Chrome plugin where you select a load of text on a page that you're browsing and you right click and you could say send to Harmony. So that's kind of in the pipeline. This is our hackathon that we ran like 3 months ago. So the winning team added some more multilingual capabilities to the tool. The runners-up, I really like their solution, which was a massive, A1 piece of paper done in Sharpie with a design for how the UX should look. So that was really good fun. We've got a challenge coming up on a website called Docs.AI, where people are basically being challenged to improve our matching algorithm. In other words, to fine-tune a large language model potentially. I have never fine-tuned an LLM, and I'm a bit scared it's going to take a really long time to learn how to do it, and a lot of money perhaps to do it. I don't know. But if you know how to do that, I'm really interested to hear from you. If you are interested in participating, there is a cash prize for joining that. So the QR code is there. The competition, we're still setting it up, but it'll probably be launched in the next few weeks or a month or so. That's training your own LLM. There will be another one for training for also improving the PDF extraction. But I think the training your own LLM is pretty exciting. Just very, very brief segue into, I have another project that's ongoing that's also got a really tricky PDF parsing, which is in the pharmaceutical. So this is a tool for measuring the risk of a clinical trial failing. So here we have a similar task of extracting data from unstructured PDFs. So just like the psychology studies, we've got, when a clinical trial is run, you have a PDF document. So here's one of them. I don't know how many pages it is. Okay, this one is short at 113. That PDF has the endpoints, so what's being measured. It has the number of people participating. It has let's say, it will say things like the people participating in this trial have to come in every day for a week, or every week for a year, and all those things that base all these details, and they're written in plain English. And what we're trying to do here is to produce a risk assessment of this trial failing. So when the trial fails, that means it's a waste of money and also a violation of ethics in theory, because human subjects have been recruited and they've participated in something that put their health at risk, and there was no advance of medical science or policy change that resulted from it. So we have this risk assessment. We've assessed that this trial is high risk, based on its phase. Number of subjects is very small, for example. So this is a tool that flags those things. And we're working on this to predict cost. So this is quite an exciting kind of tool that's very, very similar, related to the Harmony project. At that point, I'm going to end what I was showing. So that's the clinical trial risk tool. That's the link to that one. Harmony is at harmonydata.ac.uk. This is our Twitter and GitHub links. And at this point, I'm happy to take any questions. Thanks very much for listening.
I'm now going to hand over to our second presenter of the evening, Vikram, who's going to be talking about implementing AI-driven product innovations. Thank you, Vikram.
Thank you. All right. A little bit about myself. I've spoken to a couple of you here, but I am the lead product manager at Groupon. I handle two tribes in Groupon. The first one being bookability, so where you can come and actually book deals. And the other one is called the Innovations Lab, and that's kind of like a signals team. Some department says we have troubles with something, we are dropped in, we have to build a hypothesis and figure out what the MVP is going to be. We'll get into it in a bit. My education is in engineering. I was an engineer way back in the day, and I've been a product manager for about 8 odd something years now. All right. My talk is, well, it's about this mostly. I'm sure most people know this, but for those who do not, this is the hype cycle. This was built by Gartner. And it tells you the different phases that any technology goes through when you're talking about any emergent technology. Today we're talking about AI, so we'll talk specifically about AI. There are 5 parts to this. The first one is going to be a trigger. Second one's going to be expectations, inflated expectations, disillusionment, enlightenment, and a plateau. Now, how this adds up, this is from 23, but you can find a similar one for 24 when it comes to AI technologies. This explains to us where we are right now with any AI technology that we want to adopt. Right? Today, we're talking about generative AI. That's what is the most common out in the market right now. The reason why I want to talk about this is because I was talking to Hugh. There have been some things that we call AI winters, where funding stopped, people stopped working on AI. And if we keep following cycles like this, where you have massive expectations of any technology that comes out, and then you actually get no ROI for that investment, that's when companies start pulling money back, and we don't want that. We want the innovation to carry on. And the better we understand this, the more successful we can be in taking that forward. Right. As a product manager, might not be as technical as the last talk, might not be as technical as the next talk, but from a business perspective, this is my life every single day with bad spacing. But that aside, the reason why I want to talk about this is to understand how exactly do companies think of using AI in their day-to-day lives. We don't want to force AI into a solution. We want to find the right space for it. What's happening right now, companies, they want to say that we are at the forefront of adopting AI. They'll say, okay, we've got this AI. Where do we use it? That's the wrong way of going about it. You are shoehorning AI into a solution. And that's where this comes in. We want to understand what the business objectives are. Once you understand what the business objectives are, you build a hypothesis saying, this is the problem that we've got, and this is how we're going to solve it. You come up with a couple of feature ideas, and that is when you say AI can possibly help in these particular areas. You don't say AI should help in these areas. You try to figure out what's the right thing. Now, going through this entire thing, till about the ranking and prototyping stage is where you should figure out whether you are going to be using AI for a particular solution or not. Excuse me. At the ranking stage, we try to understand why exactly AI would be utilized in this particular area. And we'll talk about this in one of the later slides. There are 2 things. One is AI can be constantly on. So if you're doing any kind of analysis, that can constantly be on. A human does not need to do that. Or if you're saying that the effect, impact of an AI feature is something that's going to be much larger than what a human can do because of errors, because of the amount of time it takes, that's where you put that through. So this is a normal product roadmap. But like I said, we need to focus on the first 4 to understand whether AI should be used in that stage or not. Right. There's 3 basic things that I like to talk about whenever any stakeholder comes to me. Stakeholder, for those who are not initiated, is just people that you have to work with that might be consumers of the feature that you're making. The first one is bias. I'll give you an example. Like I said, I'm from Groupon, and Groupon sells deals. They sell vouchers. If we were to slice the data that's given to Groupon and we said, okay, we want to use AI to build the best deals we can for our merchants, we start going and looking at our data and we say, the best deal that sells on Groupon is a massage deal. Okay, but that's because we only have massage deals, right? So you will have that kind of bias in your data. So we have to understand that we need to make sure that what we're training our AIs on is not going to be biased data. The next one is explainability. And the reason why I'm talking about this is because of the large adoption of AI, a lot of people treat it like a black box. Like, okay, we have some input going in, we have no idea how it works unless people like Thomas help us understand how it works. But most people don't care. Most people will just say, this is going to be the input, I expect this output. And the problem with that is if you give it very, very large problems to solve without breaking it down, you have no idea how it got to the output once you've given it the input. So explainability is that part of it where you potentially should break down your problem into the smallest possible solutions and then see where the output is as expected. This becomes a bigger problem once you're scaling it. So again, as an example, Groupon has 1.5 million deals. We can't honestly check that, and business wants to check that. They'll check a sample set of 500, 600, but if you automate that and you suddenly see a dip in your revenue coming overnight because you turned that feature on, that's not something I'm going to be happy with, and you will not be able to explain that. And the last one is going to be evolution, and it's fairly straightforward. When OpenAI and ChatGPT became famous, I mean, what we were at the most powerful a year and a half ago was 3.5 turbo, and today we're at 4.0. I'm not going to say which is better, but it's different. So if you built something way back then, and if you're still using those models, and today it's completely different, the output you're going to get is massively, massively different. And what I mean by that is, as an example, what we used to do is we used to force types in our prompts. We used to say you can only respond in this. 4.0 can do that for you now, right? It's very, very different, and you need to make sure that you're keeping abreast with that stuff. All right. The reason I'm stopping here is because this is a question that was asked in one of the last talks that I did. Does GI/GO still exist? Does garbage in, garbage out still exist? I don't think it does anymore, especially when it comes to LLMs. And the reason is, you say whatever you want to say to it, it kind of gets the context from it, it tries to get the context from it, and it gives you the output. Now, when people making decisions see this, they think that that solution is working. It very well might not be. So for whatever input is coming in, if it's garbage, they only care about the output and they will overfit that output. Right? We need to understand what the use cases are, and we definitely need to test with bad input. And the last thing that I've said is a feedback loop. So a lot of times when we have features, so I'm talking about customer-facing features. When you have customer-facing features, you might have a feedback form at the end of it, and you say, okay, at the end of the quarter, 20% of our customers didn't like this. Why are you waiting for that? With something like an LLM, you can have the output generated almost immediately because you can use that feedback as the feedback prompt. These excuse me, these are some of the ways where the paradigm has changed when it comes to garbage in, garbage out. That no longer exists, and that's something that businesses should be aware of, and a lot of them unfortunately aren't. All right, so enough doom and gloom. Let's talk about some of the ways that it actually has worked for Groupon at least. Spacing is really weird. That looks fun. So, like I said, Groupon sells deals. One of the things that we built is going to be a deal optimizer. So what I mean by a deal optimizer is when a deal comes onto Groupon, it's a static thing. It has a title, it has images, it has pricing, right? The most important stuff. You have some text as well, not that important. It doesn't affect conversion that much. But for the rest of it, it becomes a static thing which does not change unless a human looks at it. And the only time a human would look at it is if the metrics were off. But for 1.5 million deals, you can't look at all of them at the same time, right? So we had to build a feature which helped us look at all these deals and look at whether 3 factors should be changed: the product category, the pricing, and the customer behavior on that particular. So what I mean by customer behavior is going to be the images and the titles. I don't know how many of you know, but Netflix, as an example, changes the poster for each show depending on who's watching. In the same way, a lot of e-commerce websites, they change the image that's shown to the person depending on the persona that's surfing. So that's customer behavior. All of these three factors are things that we can break down. The big problem here is how do you optimize a deal? Now, we can't just say, okay, how do you optimize a deal? You really have to break it down and say, these are the problem areas, and this is what we need to build AI features for. What we found out is that if we ask it to do okay, so really quickly, Groupon is very cyclical. Groupon sells most of its stuff in Q4. Again, you have to slice your data in such a way that you don't take Q4 and compare it to Q3. Everything's going to fail at that particular point of time. But when we took that into consideration, we are able to dynamically keep changing prices depending on what customers are doing on the website today, what they're searching for. We can check for search volumes, we can check the personas that are coming onto the platform, we can look at what's the density of that particular service in that area, and we can keep changing the prices. And what we found out is that our conversion rates have actually gone up by 45% for a test. I haven't put that there, but our test was for about 30,000 deals across Northern America. This is one of the ways, again, like I was saying, break the problem down. Even if one of those things had worked out, that's perfectly fine. You don't need to optimize a deal. You can just optimize customer behavior where you can change the images, right? And your problem is solved. You don't need to say the big thing needs to be solved. Right? The reason why we did this is because it would have taken 5.25 million minutes to change the stuff that we had to change using this feature. That's about 10 years if it's done by one person, and if they're working 24/7. That's not going to happen. Second thing, like I mentioned, this is based on consumer behavior on demand. This is not anecdotal information that a human says, I think the image should be this. No, it's live, right? This is exactly why we made this particular feature. And the next one, I'm sure that you guys has anyone sold anything on eBay over here by any chance? Yeah? Okay. So eBay does this really interesting thing where you can upload an image, or you can see other stuff that is for sale, and you can say, I want to sell something like this, and it figures out what the deal is supposed to look like. And when we did this, we wanted to, when you're trying to sell something, if you're a cafe, let's say, as a cafe, you have a coffee, you have pastries, you might also have, I don't know, something to drink, alcohol. What should you sell on Groupon? You're not going to sell all three of them. It doesn't really make sense. But the unit economics don't really make sense to bring all three onto Groupon. You bring any one of them on, maybe. But we want to understand, the merchant doesn't know the seller does not know what sells best on Groupon. Why should they bother? Why should they reach out to us and find out what's selling best on Groupon? We should be able to figure out what the merchant has, what the seller has, and get the exact supply that we require on the platform at that moment. Right? If we're not doing that, then we're missing the boat over there. So what we do is we go to a merchant's online properties and we try to understand what exactly they have. Now, online properties could be anything. Some of them are a bit in the gray area, as we will talk about. And like I said, we understand what exactly the merchant has to offer us. We compare that to what our current demand is on the platform, because we know what search volumes are going to be coming in over the next 30 days at least. And based on that, we onboard those deals onto our platform. So what that's doing is it's reducing the gap between our supply and demand. If we find that we need something today, it would take a salesperson X amount of time to go and find a merchant like that and to seller like that and to onboard that particular deal onto Groupon. And by that time, that demand has completely vanished. So that's one of the ways that this project has helped us. It has also reduced the onboarding time by 70%. Now the thing is, for me, that's not a big deal. It's a good vanity metric, 70% reduction in onboarding time, cool. But the thing is, as a seller, I want to sell stuff. So if your platform is good enough, I don't care if it takes 5 minutes more to onboard onto the platform. So it's metrics like that that are nice to show that yes, it is improving efficiency, but you need to make sure that the ROI on the project is actually something that you will be able to go to business and say, I need funding for the next AI project, because at a certain stage, again, because of the hype cycle, you might be at a place where you're not able to go and show them the ROI on that. Yeah. All right, so the first line is the gray area that I was talking about. You are not allowed to store the reviews from Google Maps, from Google Places. You can, and you cannot do any computation on that. You can use, this might get pulled off YouTube, but you can use Appify as a third party to scrape Google reviews and to store them. And the reason why we do this is because we want to understand, again, as sellers, how exactly can we cater to our customers best. A customer might say, this cafe has fantastic pumpkin spice latte. We know that the customers like that. We can target that particular merchant and bring that onto our platform, because we know the demand on our platform is for a pumpkin spice latte. And what we're doing is in data sciences, as I'm sure you guys know, you've got ETL, extraction, transformation, loading. So for the transformation part of it, because it's such noisy information that we're getting from scraping the internet, we want to shape it, and we are using LLMs for that because we do understand in what way and what form we need it onto our platforms. Me as a product manager and a developer 10 years ago, no-code and low-code solutions are fantastic. You can build really quick MVPs. You can use something like NA10 if you want to have a low-code solution. You can use Make if you want absolutely no coding effort into it. And the reason why I'm talking about these solutions and building MVPs is, again, when you can go to business and you can say, this is the output that I've gotten, and keep the expectations real. Because business will come to you and say, I want this entire thing automated, and this is the result that I'm expecting from this particular feature. You can build an MVP and you can say the hypothesis is not true. This is what you can expect. So tempering expectations is something that you should do with MVPs. And the last thing I would say is, you do not want to shoehorn AI into a place. AI is a fantastic tool. I mean, people are doing amazing work with it. And I genuinely believe we shouldn't tarnish it by saying we let business make a decision based on the fact that they want to use AI for whatever rhyme and reason, without understanding what the return is going to be. Right. And that's about it. I think for this group, the first one's going to be enough. Cautious optimism is key. Again, it is a great tool, and I'm not saying that we should not be using it and we should be wary of AI. We definitely should use it. All I'm saying is we need to temper expectations, and that tempering of expectations is mostly upwards, it's not downwards. Managing expectations. All right, then that's about it for me. Thank you.
Hi everyone, I'm going to take next 15 minutes along with Nidhi. So I'm going to run you through generative AI, which is the buzzword right now, and its use cases. So I'm not going to run through everything because the time is limited. Let me introduce myself first. I'm Shubhangi. I work in data analytics at ICS. It's Microsoft partners in the UK. Today I'm going to cover first about generative AI and natural language processing. This is very niche to the sector that I work in. And I'm going to run through Q&A relevance. So generally when people go around, ask questions, right? How do you know the answer is correct to the question that you've asked, right? So Q&A relevance basically is a method that tells us that the answer provided for a particular question is meaningful and accurate. So generally most of the people, they use some sort of similarity algorithm or vectorization to determine that if a particular answer is correct or not. But with the advent of LLMs, it's a different approach altogether. So if you see these three boxes here, so the first one is generally question and response that we provide to understand. But with LLMs, because we have context and picture, we can provide context as well, which is like if someone is asking a more sort of generic question and we provide context, the LLMs can recognize what the topic is about. Now these three things are passed on using LLMs, Python and prompt. For that, I have used prompt flow, which I'm going to explain in the next slide. This actually helps you to put all these three things into perspective. We utilize the power of LLMs. The Python script is basically used to tailor to each particular use case, and then the prompt is basically used to ask the right question. You obviously have to select the right ChatGPT model to enable that. And finally, it provides us with a numeric rating. Now, what's the benefit of this? Essentially, generally what happens is like if you use similarity algorithm or some sort of vectorization method, it gives you an output. But when you compare it with actual user ratings, you might find that the outcome is very different. With LLMs, because context is in play, it helps to understand the answers better and provides more sort of proper outcomes. So this is the UI of the prompt flow. If you see on the screen, it's part of Azure ML. There are certain standard flows and chart flows which are already provided in the tooling, and you can build your own customized prompt flows in that. This provides you a combination of both LLMs, Python and prompts as well, and you can create your own classification algorithms and also your own standardized programs. The next thing I'm going to cover is matching algorithms. It's also the same thing that I've worked on using prompt flow. So for anyone who has worked ever on some kind of matching algorithms, they're basically used to assess the compatibility between two data sets and helps to find the best sort of option from that. So with LLMs, there are three prime benefits of performing matching algorithms. First is the semantic differences, where two words which more or less they mean the same thing can actually be identified better. So in natural language processing, generally they are identified differently. But with LLMs, if you're working with NLP, it actually enables to normalize those differences. Second is adaptive matching, which is like not only taking just the data in place, but you can also use the real-time user behavior as explained in the previous presentation. And then lastly is the contextual understanding, which is really the key here, because if the context is not clear, it's not going to give you the right kind of outcome. So matching algorithms can actually be more enhanced using this technique. You can implement this using prompt flow or any other approach, but I've personally been using prompt flow. The only limitation is that you can only use 1,000 records at this point in time because of the limitation of tokens, but that can be resolved if more tokens come into play. And now on this note, I will hand over to Nidhi, who is going to cover something about women in data. So this is the London chapter that we'll co-lead. So handing over to her, and happy to take questions afterwards.
That is what we want to do. We wanted to bring more and more women in this industry, educate them, make them aware, and definitely the opportunities that lie down here. So moving on to the next slide. So as you can see, our impact. So definitely we do a lot of events, like recently we did a datathon. So in terms of our engagement, there has been 22,000 people who have participated in our events so far. We have across 5.7 million people who we have touched their lives. So just to add, we also do charity. So there are a number of events which run across the different locations, and different chapter leads, they raise money. And all this money goes for girls' education, for sure. And then definitely the number of members that we have. So just talking about London chapter, we have around 300 members who are enrolled for the London chapter. And if you want to know more, you can just search on the App Store, Women in Data WID, and you should be able to find about. So definitely there are 4 major things that we do. So learning and development. So we have a lot of courses which are available, and anybody can enroll on those courses. We have mentorship. So we have one-to-one mentorship opportunities for people. Definitely a big network that we provide to everybody, and career advancement. That is what we help in. It also talks about our mission, vision and values. What I love is definitely the code, which is our values, so which talks about community, opportunity, and yeah, I'm not wearing my spectacles, so forgive me for that. Now talking about events so far, so I started this chapter in January. Me and Shubhangi started working on this, and we have done various events. So we do meetups every quarterly where we meet women, and we share different ideas. We have diverse group of girls who come across, and what problems they are facing, what are they studying in terms of education, in terms of the work they are doing, the challenges, and definitely there is always something to learn about within the group. Apart from that, we also got an opportunity in the Big Data and AI event where we did a moderation for the CDO panel. It was all C-suite, where we had the opportunity to moderate around 16 plus C-suites people. We also had a roundtable opportunity at the Big Data and AI, which was a great platform as well. Apart from that, we do monthly events which are either online or in person. We have invitees which we invite from different companies also to speak over, and we do our own study material which we share across. Now in terms of upcoming events, so we also started thinking about just not looking at AI and data, but to also look if we can do something on mental health. So we are doing a yoga session which is scheduled for this Friday. And I work for data governance at UBS, so a lot of requests started coming. We also do polling within that, what topics people are interested in. So definitely data governance is something, and I think very much needed in the AI sector. It's the booming topic going on. So we will be doing definitely an event on data governance. We are also doing a lot of collaboration with other like-minded organizations, and there is something which you might see Q1 next year. So just wait and watch what we are going to bring in. Apart from that, we are having guest invites in place. So we will be inviting people who will be talking about their journey. We have some very interesting guests in line, so which we will be inviting, and definitely panel discussions, and a lot that we will be doing with you. So thank you so much for this opportunity. And yes, so with that, if you want to join us on LinkedIn, so that's our details. Any questions anybody is having? Thank you so much.